Welcome back to the shop, I'm Oscar as always, and I remembered I forgot something. In the video about motor drivers and servo drivers, I said that one of the simplest drivers there is an H-bridge driver, and that I was going to explain to you how it looked like and how it worked. Now, for some reason, I never did this. I realized that when editing the previous video. So, let's do that, I guess. So, why is it called an H-bridge driver? Well, that's going to be made clear to you in about 5 seconds. And this is the complete electrical schematic of an H-bridge driver. So, what is it used for? Well, it's used for reversing the direction of a DC motor. Because by closing this and this breaker, or this and this breaker, we can decide which direction the polarity is on the motor. Since if we close this and this breaker, we will have the negative lead on this side of the motor, and the positive lead on this side of the motor. And if we do the reverse, we will have the positive lead on this side of the motor and the negative lead on this side of the motor. Now, the limitation with this type of driver is, of course, that it's built for a DC motor, not an AC or BLDC motor. But that being said, maybe for a small robotics project, or the traverse motion on a lathe carriage, or the rapid traverse on a mill, something like that, this will work just fine. And now I'm going to show you a couple of different versions of this driver. Just for fun, I built this. Here we have a DC motor, and to be more precise, it is actually the motor from the window elevator of my old BMW E46. But that car is long gone, but I still have a couple of these laying around, since I had to replace the door twice. And I have 2 buttons here. And on the back here, you see 4 contact blocks. And these are just 4 regular, normally open contact blocks, nothing fancy. So let's hook up this circuit and power the motor. And here we have the simplest H-bridge driver there is. We have the incoming power from my variable power supply, going over here to the input side of the buttons, and I reverse the polarity when going to the right pair of contact blocks. And here, of course, we have the output going to the motor. So if I push the right hand button, the motor turns clockwise. If I push the left hand button, it turns counterclockwise. And for a really small load and small motor like this, having the power going directly to the buttons, it works fine. But sometimes you need to switch a heavier load. And I really wouldn't recommend pulling more than maybe 40 or 50 volts through the buttons directly like this. In this case, I'm using 12 volts. Then you will need some type of intermediary step or power electronics. such as contactors or relays. So now I'm going to hook up this using a couple of relays instead to show how that works. And here we have exactly the same thing as previously, with the one main difference that instead of having the power going directly through the buttons and then to the motor, the buttons now turn on either this relay or this relay, and the power goes into the relay then to the motor. So the only thing we have over in the buttons is the control current. And in this case, I'm of course using the same 12 volts to the control circuit, the buttons, as I am to drive the motor. If I were using a bigger motor here, let's say a 150 volt motor, the motor wires, the motor leads would of course be at 150 volts, but the control circuit would be at 12, 24 or 50 volts. And this is how you build a standard control circuit for industry applications. And you can find equipment hooked up exactly like this everywhere. And we can of course now control these relays from some type of logic circuit, let's say a PLC or a microcontroller. Now there are some relays you can control from a microcontroller directly that run on 5 or 3 volts. These two however run on 12 volts. So to pull these ones you would need a PLC or some type of power circuit between the microcontroller and the relay. And while relays and contactors are extremely useful for switching heavy loads, such as motors or pumps, or well, all pumps have motors, but you get what I'm saying. The only thing they can do is reverse the direction of the motor. If we wanted a bit more control over the motor, we would need something a bit more sophisticated. Something like these. These are logic level power MOSFETs. And on this model you can see that they are logic level based on the L on the end here. And I'm calling them logic level because you can turn them on and off from a logic level output on a microcontroller. So 3.0 or 5 volts. I think these ones are built for 5 volts. And we can hook these ones up in exactly the same way as we hook up these relays. As regular switches. 2 of them for turning the motor clockwise and 2 of them for turning the motor counterclockwise. And since these enable us to be able to control the motor directly from a microcontroller, it opens up a couple of different possibilities, some of them quite interesting, such as higher switching frequency. And a higher switching frequency means pulse width modulation, and pulse width modulation means control of speed of the DC motor. So not only are we able to change the direction of the motor, we can also change the speed it's running at. And since we can change the speed of rotation, it would be quite interesting to have some type of feedback on speed or position of the rotational axis. And if we implement that correctly, we have a servo system. But that is an upcoming video. But before I end this video completely, I'm going to show you the electrical schematic of how I hooked up the relays. And I also hope you noticed that this time I did build to scale and paint it. And while this might not be the prettiest electrical schematic I've ever done, it is completely sound electrically and logically. So in this case, S1 and S2 are our two buttons, K1 and K2 are the two coils on the relays, and the coils on the relays of course close the switches that power the motor. And you can see here of course I reverse the polarity on the motor depending on which of the contacts is closed. And this is of course only one way to draw this type of schematic. Every company I worked for or whose machines I worked on have different standards and different ways to represent the same thing. Germany have a different one, Sweden have a different one. Now doing it this way is quite common almost everywhere, but you could also have a completely separate control circuit where we only have the annotation K2 here, and then we have a separate contactor coil over here, with of course the switch actuating it. But that's not really important. And one thing I forgot to mention when talking about implementing MOSFETs for an H-bridge driver is that there actually exists complete ICs that are integrated H-bridge drivers, which comes in a small dip package with 6, 8 or like 12 legs. And a couple of those are used to control the motor, and a couple of those are used for control functions. Now you will see these quite often in small hobby electronics packages for like small robots and stuff. But for turning heavier loads or powering heavier motors, you need something a bit more beefy than those. They probably work okay up to maybe half an amp to an amp. But if you need more than that, you definitely need to have some higher capacity electronics. And on that note, it's time to end this video. I hope you found it interesting, and now you should definitely know what an H-bridge driver is and how to use it. And this also gave me some ideas on upcoming projects and things to explore in the future. But until then, take care and stay safe out there, and if you have any questions or comments or anything you want to make me aware of, don't hesitate to contact me. You can find my contact details down in the description. There's both my email address, my Instagram, and of course the comment section below this video. And if you want to, I'd be happy to see you check out the Amazon links down below. You can usually find most of the stuff I use for these videos and the stuff I use to build my Queen Bee Pro CNC. And in doing so, you support me, you support this channel, and it really helps me to be able to create better videos for you guys with more interesting content. And on that note, let's end this. Take care, and till next time.